Hello, everyone. Welcome to today's community call. Sorry, we're starting a few minutes late. I just had to do final touches. We have quite a few people on the agenda today. So very excited to introduce them and show you all that we have. As you saw, we're going to be talking about some robots. We're going to be talking about using agents in many, many different ways. And then we also have Emmanuel here talking about how he's using it for an offline AI tutor. So let's get started real quickly. Before we do that, though, we have a few reminders. If this is your first community call, first off, welcome. Thank you so much for spending your time with us today. We have a few places that we chat. So we chat in the YouTube channel. You'll see that there, and we'll get those right away. So if you put those in there, put questions or comments, we'll address them on the live stream as they come in. And while we're getting started, if you want to test that out, let us know where you're watching from. It's always very fun to see that coming in. So if you want to start saying hi in that channel and let us know where you are, that's always cool. And then the other place that we can do that is in the Discord general channel. And so if you're not in that channel already, that is the place that outside of the community call, we're talking every day, all day about all things Dagger. So please join that if you aren't in there already. And we can answer questions live in there as well. And then also, if you're watching this and you have a very cool demo to do, just like all the individuals that are here with us today, you are more than welcome to do so. Just DM me on Discord and I will add you to the agenda. So let's get started. Let me remove this real quick so we can see all of our amazing guests today. So, of course, we have our co-host Jeremy here with us.
Hey, Miranda. Hey, everybody.
Thank you so much, Jeremy, for joining. So Jeremy and I partner on all things ecosystem community and get to talk with amazing people like this, two of which we met at the London Hack Night. So very excited to have Costume and Igor here with us today. Do both of you want to just quickly introduce yourselves, and then we'll point to our Dagger Commander Emmanuel after.
Absolutely. Hello, everyone. I'm Kaustubh. I'm a freelancer, freelance software engineer from London. I'm excited to be here.
Awesome. Thanks for being here. And Igor?
Yeah, first of all, thanks again for inviting me. My name is Igor. I work at Neon on the agents team. So we are a database company, but as everything is changing, sort of right now, we are looking what to do on the space between agents and databases.
Awesome. Good space to be. And then we have our amazing Dagger Commander, Emmanuel. You want to introduce yourself for people who may not know you?
Thank you. My name is Emmanuel. I'm a software engineer at a private equity. Here to discuss a thing I'm working on my private capacity.
Awesome. Very, very excited about this passion project of yours. Okay, so let's get into it. Because we have so many demos, I want to get started. Let's do this.
Which one do we pick first? Oh, we got
first. So the first one we're going to go into, the official title, as we all see here, is the Robot Operating System Replay. But Costume, you want to go into just, or I guess you're probably going to get into the slides, but get into a quick intro. First, just right before you do, let's set the context for everyone to see where this demo came from.
Absolutely.
The hack night and things like that. Would love to see how you came up with the idea.
Yes, sure thing. So I am a freelance software engineer based in London, and which means I jump between projects with different companies here and there, and then I pick up these new tools from different companies. And I was introduced to robotics during my dissertation project, where my supervisor, he just suggested that there's this really cool computer vision project that we're building, and if you're interested, you can take it up as a dissertation project. I said, all right, yeah, why not? I'll learn something new. And to be honest, when I walked into the Dagger hackathon, I had no experience with Dagger at all, and very little experience with robotics too. If I define very little, it was the dissertation project was the only project that I've built with robotics. But I remember you guys had two pathways for the hackathon, right? One was the AI agents, and the second was pipelines. So I thought, all right, most of the people around me are building AI agents using Dagger. Why not experiment with pipelines? And something else that I recently learned, that is robotics. All right, let's combine them and see what can I build based on, of course, this is built based on limited experience that I have. And after this demo, of course, I'm gonna make the repository public, and I'm going to talk to some other people who have experience with robotics to improve this. And anyone who's on the call has some experience with robotics, please feel free to reach out to me. We can build on top of it. So I'll just give you a walkthrough of what this project does. But before then, let me give you an over. Is my screen visible? Right? Is the presentation still visible?
Yep, looks great.
Great.
It's in the share mode, so it looks perfect.
All right. Yes, perfect. So ROS, right? ROS uses a pub submodel, which means nodes talk to each other using topics. Now, these topics have specific message type assigned to them, right? Now, for example, if one node is publishing an image to a topic, but the other node is expecting a string, now that's a problem, right? Of course, if we have one or two packages, we can manually check what type of message that it is expecting or what dependency it is using. But when you have 10 or 15 or maybe 30, 40 packages, you can't manually go through all of them. You run them. I spoke to someone who has some experience with robotics, and he said, I just write my code, I push. If it works with the others, it works. Otherwise, we talk and call, we check what is going on, what is going wrong, and then we make the changes. So I thought, all right, why not use Dagger to analyze all these packages, right? So what my project, this is where ROS replay comes in. So it analyzes all the ROS packages that I've mentioned in a JSON object. It parses all the dependencies, right? It checks what publishers are present, what subscribers are present, what data types they both expect or they put forth. And then it flags these mismatches. And it also goes through the dependencies for all these packages. And then it creates a report that it can either email it to someone, or it can just show it on the terminal, right? So this is how the structure looks like. So I have a run pipeline set up, the spin up function. So before I explain a little more about this, I'll just quickly run this in the background so that we can see an output of, So if I run this pipeline, and now while I'm explaining, it'll go through the whole thing. We'll get an email report soon. So the spin up actually installs all the dependencies necessary for these ROS packages to be executed, right? It can also include Python and other pip dependencies that we have. The gatherer is responsible for cloning all the repositories that we've mentioned in the JSON dictionary, in the object. And then the watchtower is where the actual logic happens. It goes through every package. It understands what the subscribers are, what the publishers are, what type of messages they use. It goes through the dependencies, and then it creates a report for us. So I'll just quickly show you an example of somewhere where a mismatch does not happen, which would look like this. So we have runtime dependencies for these three packages: nav human communication, test robot control, and ROS turtlebot 3 test. Of course, these two are like test packages that I built just for the demo. And then so these are the dependencies that they have, the X's and the tick marks. So one thing to note here, the X's don't necessarily mean there is an error. It just means it is not being used right now. So by that package. So this list is the dependency list, and then we have a subscriber and the publisher table, where so this is the topic that I showed you earlier in the image. The message type it expects is an image. This is the package that is publishing or subscribe to it, and so forth. And at the bottom, you'll see a message, no message type mismatch found. Right. So here we are in the clear, but we have, oh, my bad. So I have this set here, email equals to true, which just sends us an email with the report. Oh,
and then in that table that you were showing us, I saw that there was no overlap in the different message types. Yes. In the case where you had, I think like the two test packages on the right required Turtle Sim or something like that. They both required Turtle Sim. Could it be that they need different versions of Turtle Sim and that could conflict at some stage?
So these are the topics. So if we have a specific topic, you won't have versions of different topics by different packages, but you might have different message types supported for different packages. For example, if I have created my own package, which for example, it creates a new topic called let's say /dagger/ group information, right? Now it is my responsibility to understand what type of information is being published to that topic. The publisher can have it as simple as a JSON data, or maybe a pose or an image, right? So the subscriber will just understand what is a message type, and then use it. So there are these tools that ROS provides where you can visualize the whole thing like a mesh. But for that, you actually need to run the whole thing. While these packages are running, like while these nodes are running, you see the whole graph. But what if I'm just working on one package? And that was my case, right? I was just building one thing, and I had no idea what the others needed. So this is why I thought of ROS Replay. And I'm sorry, my screen stopped sharing for a few seconds, but we can see here, email sent successfully. So once we go over here, and this again, we can see there is no mismatch. But let's say I do want to make a mistake. I go here. This is one of the packages that I have. Let's say I change this pose to a JSON. If I commit the changes, it is in the main branch, which is being used right now. So if I run this code again, it will take the latest code changes, right? It'll notice the difference where I'm publishing as a JSON, but I'm using it as a pose. There we will have a conflict. So it highlights that in the email. And if sorry. Okay, so I have sent the email right now. So as we see in this, we see message type mismatches, topic total one pose, published as JSON by this package, but is subscribed as pose by this package. Right. So we see that there is an issue here which needs to be addressed, and that is what ROS Replay does. It also gives you a dependency table. It also gives you like a table view of the subscribers and publishers. But this is the bottom line. It just highlights what is a mistake here and what needs to be changed.
Oh, that's nice.
Of course, this is built like with very limited experience, but I want to talk to others who are actually building bigger projects with ROS, right? And maybe this could be helpful for them because you can build C++ nodes and even in Python. So this just supports Python right now, and there is no AI included. So maybe I could use AI to understand other best practices, and maybe there are these URDF files which describe a robot structure, like for example, an arm, like or a camera's eye, and those things, right? So even that can be further processed. So I see scope here, but with limited experience, I can only build smaller parts of this, and I want to keep on continuing to build this forward if that is going to be useful for the ROS community, of course.
Oh, that's great. Yeah, it'd be exciting to see if there is some spot where it makes sense to just, just stick in an LLM type and maybe pass something and get some analysis back if it's something that turns out to be useful. But that's very cool tool.
Exactly. So yes, that's all from my side for the demo. If anyone else has a question as well.
Awesome, thank you. Yeah, it's very cool to see, and we have a lot of different use cases in our Discord. So I'm excited to have you in our Discord now, and we got to meet you in person at the event. So I'm excited to see where the connections get made, within the community, not only on Discord but on our demo forum, things like that. Because if anyone is interested in it, as you know, we go into our Discord and we add it into our demo forum as a snippet. So if anyone has questions on this or wants to connect with you, I will make sure to tag all of the speakers in those demos, and that way, if anyone wants to connect individually, you are more than welcome to do it there. So thank you so much for your demo. I really appreciate it.
Thank you for inviting me.
Yeah, of course. So let's go and add, I think the next person is Igor. What are you going to be talking about today?
Hey guys. I'll be talking about a bit unconventional use of Dagger for language models, because from what I've seen, most of run language model inside, but we are doing something a bit differently. Mainly tree searches, which requires us to run parallel completions, and hence the architecture is a bit inverted. So we have LLM outside, and we have Dagger serving as a canvas. Reproducible, isolated, where we can invoke any command, install any package, and see if the code works. So without further ado, what have been built on the hackathon? So I had a couple goals in mind. Basically, why build this? In my high school years, I've been traumatized by finding the limits, and the habit basically sticked. So priority one, I wanted to test the limit of a Dagger as alternative to sandbox services, such as like E2B, model sandboxes, and other proprietary stuff. But first, Dagger is open source, it uses Docker, and it's fast. Second, I wanted to test how good language models are at working with, let's say, a bit weird tech stack. And third, it was a hackathon, so I wanted to build something silly. So the stack. Any applications needs something to manage the infra, your Terraforms, your Pulumis, Kubernetes, and the stack to build application. So since I'm in a database company, I wondered, can my whole stack be just Postgres for the application layer and Dagger for the infra? Now, it's a bit more complex than that, since I'm mostly a Python developer. So like Python might occupy all the RAM on my computer, but Python occupies a single brain cell in me, and I consider this acceptable trade-off. So what are we building is HTMX and Pico CSS. That's what we have. So let's see how it looks like. and why Dagger basically is the MVP here. So we can look at this simple script. Create some tables, inserts a couple values, and now the magic happens. So as you can see, I'm invoking the curl, and all I have is a SQL script. And I get a JSON output. Now, that got my mind racing. If we can return JSON from the Postgres, what can we actually build with it? If we take a look under the hood, how it works. So the workspace setup is not extremely complex, but it has a few interesting quirks. So the command that I'm executing, so exec all, what it does, it spins up container and runs pgshim. It's important because it ensures that the command will be executed whenever the database is up. Because when you run in parallel, sometimes you strain your EC2 instance, it's not ready yet. So better, this single line is enough to verify that the database is ready and you get no false positives. So the setup consists of a Postgres, which basically converts Postgres into a REST-capable service, and the third container that we use to run the commands. It can execute SQL using client and curl. I don't need anything else. So the scaffolding, we run our SQL files, we run command, and we return. Now, in terms of what we actually see, we want to build a full stack application, right? Right. What if the whole application was a single file with a .SQL extension? And it might look uncanny to see this kind of a full stack application, but bear with me. Like for a human developer, it might be hard to write a code like this with templating, certain parameter substitutions. But in the era of vibe coding, like probably for language model, it might be okay. It can keep track of what substitutions are here, what I'm selecting from the database, and probably write some decent code. So this has been generated single shot by a model with a prompt that's like, make me a Postgres application. Here is an example of some HTMX, go. And here is what it output. I wonder like, okay, let's just run it and see what we get. So to actually see what it is, like it's probably nothing special, but actually, this single SQL file generates applications that are responsive, that actually work, and are not that far from the output that you can get from probably like Replit, OpenAI Codex, or Cursor. And all of that in a typed single SQL file. Last part I want to note is basically the speed, because since we have taken a look at the workspace, it spins up 3 containers, binds them together, waits for the Postgres to spin up, and runs curl or SQL commands to basically bake our application. And with Dagger, all it takes is less than 3 or 4 seconds at most, and we get the output. Now, disclaimer. In no way I'm advocating to building applications inside Postgres with frontend. It's probably just for fun. However, the Postgres in terms of API only, so returning JSONs and having a REST API on top of your database to basically query data, you can add auth and secure it. It actually has its place and often faster than what you can do conventionally, because these applications can run right next to your database. I think I'll keep this short and sweet. So if you have any further questions, feel free to ask.
That's amazing. Yeah, it's too much. I love it. I love it. I got a chance to see it at the Hack Night, and it's like I feel like it comes across even more awesome this time. This was amazing presentation, and in terms of testing the limits, are you thinking? Do you feel like your prompt can handle kind of a number of different application types, or kind of what do you think the limits are there?
The limits are mostly in testing. So certain models have limits on how much tokens they can output. 8,000. Claude is the best in this way because you can have it continue from the same point without inserting user messages continue. So with Claude, you can go crazy. You can like generate as long as you can fill 200K token context. If you really want to push it to the limits, you can split it in separate SQL files. Nothing wrong with that. Like you can execute code sequentially and have, I don't know, your Jira clone, your whatever inside the database. So by the way, I will send it in the chat. All code has been published. Can test it, use it. I will commit some more over the weekend with the search to build something even like larger. But I think there is practically no limit. It has certain stuff with WebSockets, but it's again circumventional. There are extensions for Postgres that allows subscriptions. So you can have real-time communication with the database. And if you want to crank it to 9,000, not to 11 by having like front end with HTMX, you can do that. I'm tempted to try. However, I still have to do some meaningful work on the stuff that matters, my day job. But overnight, who knows?
Well, this is the thing. I'm going to have to open a couple issues on this repo. One is just we need like an amazing like 4-letter acronym for the name of this stack, whatever it's it's like this new standard. And then there's going to be like startups that are creating the whatever stack as a service, and it's going to be crazy. I can't wait. But I love that you're able to like you said, do all your infra with Dagger, so you have this local, well, in your case, local on your laptop or run anywhere infra, containerized infra.
Exactly.
Yeah.
It's the most important stuff because like with E2B, like if your language model generates code quickly and you break it down into smaller parts, your bottleneck becomes network latency. So when you start calling into E2B model sandboxes and their infra doesn't respond as quickly, it's the bottleneck. You switch to Gemini Flash, it like rapid fires tokens. It completes certain parts of the code less than a second, and then you're waiting 5 seconds for E2B to respond. It's unbearable. Now with Dagger, you can spin up complex deployments. Like the stuff I have seen, like you can run ROS inside it. You can tie together 3, 5, 7 containers, and it's faster than what we did with Docker purely. So before that, we had a setup where we re-implemented like poor man's Dagger by using Python SDK to Docker and doing the same stuff, but it was riddled with problems. I don't know how you guys solved it. This for grabbing the output, like with Docker, if the command doesn't complete, or like you have to wait for the service to start, and then you have to call the next command, and it fails. So you have to do all the dmax, std error, std out, and it comes out mangled. If the package you are running is doing some streaming, like those spinners, progress bars, good luck.
Yeah.
Good luck formatting it for like the way you can pass to language model. Now with Dagger, it just works, and I love it. We already switched everything to Dagger, and like stay tuned. We will release sometime, probably this summer. We will go open source with like proper agent tailored for like applications that use database. Highly opinionated, but the focus is reliability. So it should be maintainable.
Can't wait for that. You heard it here first. Awesome.
Yeah, I'm very, very excited to follow the journey. And I think like this is what is so cool about the fact we even get to host the hack nights, but because we're using Dagger as like that, hey, come to hack night and hack on things that you want to hack on. But Dagger obviously is the key here. But the nice part is we get to see all of these different outcomes of it because Dagger is so flexible and can be used for so many different use cases. It's harder, obviously, on the marketing side when you're trying to put messaging around that. But at least for just people getting to try it out, and like both of you, like you had, I think, 2 hours or something, and you got to build this. So it's amazing to see these outcomes. And also, a shameless plug to our next hack night is in San Francisco on May 14th. So anyone watching this, if you're in the area, please join us. If you want to go and let's say you really, really want to join virtually, we do actually have a Discord channel that we're actively watching during those hack nights. We won't have a Zoom or anything, but if you have questions, we will be on that channel actively watching it throughout that whole time. So if you're in the kind of same time zone but can't get to SF directly, you're more than welcome to share it there. And then obviously, like all of our other people here, come on the community call, and we'd love to see your demo. So thank you both of you for coming to the hack night, but also showcasing this. It's very cool. And you're really excited to see that launch come out this summer too. So thank you. Emmanuel, do you want to share your demo?
Yes. Can you
not a hack night demo, but it's a passion project, which is just as useful.
So I'm gonna start by giving you context regarding like what all this is. So basically, it's an AI school for software kids in Africa. I'm gonna give you context behind it first. I'm gonna explain the surrounding architecture that I built, preceding like the actual presentation itself. Then I'm going to narrow in on the first offline AI tutor that I built and Dagger's role in building an AI agent to feed data into that particular tool. So to start off with the context, I guess this is self-explanatory. I'm building an AI school for self-driven students in Africa. The question then becomes, why am I doing that? So it's a personal story. Like personally, I'm a self-taught engineer. Everything I've learned has been self-taught. And I found that nothing has helped me learn faster than AI. I mean, there's some caveats. You have to double check the output it gives you because sometimes things it tells you are like completely off. But it's like having a personal AI. It's like having a personal tutor who never gets tired of your questions. And I have many questions, honestly. And you can kind of like tailor the response that it gives you to best fit the way you want to learn. So basically an AI tutor that you can self-direct. I believe with the pace of technology, it's always been fast in general, but with the pace, things are always going faster and faster in general. So the world's always changing. It's changing faster and faster. So I think that the biggest challenges that kids who are self-driven back home have is that you have this traditional education system that is often under-resourced and overly standardized. We do things the traditional way, the conventional way, essentially. even though the world is changing very, very quickly, we're still stuck to that conventional way. And there's been many studies that show that one-on-one tutoring is the most effective way to improve learning outcomes. And anecdotally, I can confirm that from like having that AI tutor support me in my learning outcomes in general. Now, the another challenge that you'd often face in many parts of Africa, I'm starting off with Zimbabwe because that's my home, but it's a microcosm of issues that affect the entire continent in many parts, in many ways. So the ability to be able to interact with these large models, you have barriers. The barriers being that the internet connection tends to be slower and more expensive to most people generally. So there's a need to leapfrog these infrastructural barriers essentially. So what I am building is an AI school. Essentially, what that is, I give kids who are self-driven a laptop. The laptop has an offline AI brain, if you want to call it that. So a local AI model, essentially. Obviously, there's limitations regarding the size of the model I can fit into the laptop because I want to keep the hardware as inexpensive as possible. So for my MVP, I'm using like a 2013 8GB MacBook Air. The model that I found with the best, I guess, reasoning capacity that can run reasonably well on that laptop was a DeepSeek 1.5B quantized model. And then on the other side of this image is I call it the virtual campus. So imagine like a virtual campus of AI tutors teaching you different things. That's what like I call it Funda AI essentially is in a nutshell. So the reason I put the laptop in a box with like a lock is because I'm running it in a customizable OS, right? Because I want to be able to this is based on conversations I had with like a few parents back home. So right now I'm running the pilot with my nephew. So I had a conversation to understand like what are the biggest concerns they would have about that idea in general. And I wanted to have a customizable, like I guess like a Linux type OS so I can add more robust parental controls essentially. So moving past that, so the overall goal is just like build my content into a tech talent hub. That's the overall high arching goal. But it's one step at a time. So I'm starting off with like one user, my nephew as a beta user, seeing how that goes and building it up based on that. So I had a short video just showing what the virtual campus is. In simple terms, it's an app store, honestly. Like it's a way for me to distribute like the AI tutors, the desktop apps that I build, along with a library of vector embedded books, like to teach kids critical thinking skills, like read complex books guided by AI, essentially. Let's move on past this slide. Okay, so now I'm gonna hop into the first AI tutor that I built. This is where Dagger ties in. So the first AI tutor is the examiner. The examiner is essentially an AI tutor that gives you past papers or past paper questions. You answer those questions, and then it gives you a mark and feedback to basically help you prepare for exams, get better grades, essentially. So because of the context back home, we use like the Cambridge curriculum as a gold standard of education for primary and tertiary education. So I'm using that as I guess the starting knowledge base, if that makes sense, for what the AI tutor can help you prepare for exams for. Now, if you think about how this would work conceptually, right? You would have one way to go about doing this is that you would have potentially AI generate the questions and the answers, and then mark the questions and answers. But then because I'm using a small model, I don't trust the output of what AI could, even if I fine tune the model, I don't trust the output it will produce when it comes to generating those questions. So I wanted to offload that task and get a more deterministic way of getting the exam questions. So what I did was, I'm gonna start off with this part actually. So what I did was I built like a Dagger AI agent that starts off by discovering and cataloging the exam questions that I have. So I have the exam questions stored in in Google Drive, like 2,000 exam questions and answer sheets. So you have the exam question, you have the answer sheet for different subjects for different levels. Levels are like this primary school, and this tertiary school. So O level, A level, and primary essentially. So the papers are categorized by the levels, by the subject, by whether it's a question, an answer, or an answer sheet essentially, or a marking schema. So that first I guess the first method that I have in Dagger would just categorize that to find any new papers that I'm adding. Just create a list of all those papers. Then after I have a list of all those papers, I then have another method that would then look at the database list of papers to see which one hasn't been processed, and then it will process those. So what does that mean? So processing that means extracting the individual questions from each exam question paper. Now, if you imagine the question papers, right? I mean the questions themselves. There's questions, there's sub questions. And a question can have an image, it can have a graph, it can have a table, it can have different things basically. So that's the rationale behind using AI to extract that data, because I want to be able to say that, okay, this question, this sub question, it's all one question essentially. And I want to be able to clearly identify that this particular image is associated with this particular question, if that makes sense. So I have like a lot of like helper functions that are built in to extract and organize the questions, and then other functions that help to extract like charts, images, and graphs and tables. So with that, I'm looking at like things like X objects. I'm looking at text density, color density, the white spaces, because with some papers you might have a lot of white space that might indicate there's a picture there, but you're looking at the cover page essentially. So I need a way to know that like this image is the cover page or the back page or an actual image associated with the question. So once I extract all that data, I then map the images to the relevant questions. So that's essentially the pipeline to just like get those questions extracted and then stored in a database. Essentially, I do the same with the answer sheets, and then I do the same thing with the marking schemas. The marking schemas just explain like how to assign marks depending on how someone answered a particular question. Essentially, now with that done, what then happens with the AI tool itself is that I can then have a local cache. It's a desktop app. It's an Electron desktop app, essentially, right? You can have a local cache that stores the questions and the answers and the marking schema. I have a SQLite database that keeps track of the questions the user has answered. And then I want to, or rather not want to, I sync with the MongoDB, the repository of information, the MongoDB database, to get new questions whenever the user has done 75% of the questions that are stored locally. Now, the rationale behind that is that you want to have like an offline first experience because of the internet, I guess, issue barriers that you have in general. So that's the rationale behind that. So the actual interface of the app itself is pretty straightforward. Like it just shoots out a random question, you answer the question, and then you send all that information along with the actual correct answer and then marking schema to AI locally. And then that then generates a preliminary report. Now, the rationale behind that is because of I don't trust the output. I don't fully trust the output for 1.5B model. I'm sure I can get like more accurate responses when I fine tune the model like better. But a simple way to get things done for the MVP is just to get that done, get the preliminary report, and then whenever the user's online, you queue up all those questions that they've answered. You send that to a larger model and get a fuller report, like sent back to them whenever they're online. That is. So that is like the gist of what I built. This is like I just screenshotted some of the tasks that I was running with Dagger. So some of the tasks took 21 hours at the very least, some a lot longer than that. It's extracting those like individual questions from like multiple papers. So that's the long and short of what I've done so far. There's still a long way to go. Well, not really a long way to go. There's a short way to go before actually like shipping out the first laptop and then getting more output and just like building on from that. So that is my presentation.
Emmanuel, that's amazing. I was wondering, I was trying to get oriented to the Cambridge curriculum system, and I was just kind of looking up on the side this notion of how they publish past papers for the various education levels. So a paper, are they coming out in a particular format that that are pretty consistent when you're processing them? Are they like a PDF or some other, or a web page, or what kind of format are you dealing with when you're extracting the questions, sub-questions, charts, etc.?
The good thing is they tend to be consistent. They tend to be PDFs with the same structure. The older papers are a little, like you get a little more variety in that particular regard. But for the most part, I just like focus on papers that are like just consistent PDFs, same format pretty much. I mean, the differences come in like I guess how the questions are structured. Like some have images, some have graphs, some have tables. That's where the nuance lies.
Mm. No, neat. Yeah, that's a great, I mean, amazing like resource. Why not, harvest that, turn it into something you can remix into this new curriculum. It's amazing. I love it.
Thank you.
And I know, you've been a Dagger user for a very long time, so from the early days and seen it. And have you felt like with this new use case, and you having a screenshot of Dagger Cloud here, if anyone's not familiar, like, are you using it more, you think, for debugging now that you're using it with all this agent use cases?
Oh yeah, I mean, if you imagine like just like having a pipeline with 2,000 questions, if you extract if you imagine the amount of time it takes to just extract those questions from the multiple papers, I have to be like, if a failure occurs, I have to understand why it occurs. I think the cloud helps with that it makes things easier to debug essentially in many ways. There were times where the pipeline would be running for like say 15 hours and it stops running for whatever reason. The cloud helped a lot in just like uncovering what is actually going on in that particular regard. Sometimes there are timeouts.
Right.
Something simple as that.
Yeah, that's awesome. That's good. I'm glad it's useful for you, and it's great to hear. And I'm very excited to see where this project goes and seeing, are some of the functions that you were talking about, are those open source by any chance, or is that something people can look at?
I will share the GitHub repo after the call. There's actually a question that Igor asked about plans to add options to process books, curriculum stuff. Yeah. Yes. Actually, for the books in particular, there are plans for that. So, I know that with my nephew, he gets books like from his school in like sent to them via WhatsApp or something on his tablet. So I'm trying to figure out a way to process those books to actually, I need to figure out what the use case would be first before actually deciding what to do. I think it's easy to just shoot up features that are seemingly exciting, but I need to understand like how that actually help him at the end of the day before deciding what to do. But there are plans to look into that in more detail.
Interesting. Yeah. Are there particular subject areas that you're trying to focus on, versus others? Like thinking in terms of, some of the other resources out there, like Khan Academy type, resources where you've got, there's a lot of videos on, say, mathematics or other things. Are there certain areas that you're focusing on that you think are maybe underserved? Or
honestly, to be honest with you, my crazy vision is to turn Africa into like a global tech talent hub. So I'm thinking of ways to build AI tutors that can help build those core critical foundational skills. The good thing with AI tutors is that you don't have to be. I mean, there's always this feel that you have to be you have to have a specific niche to narrow that and be a domain expert in a particular niche. But I think the beauty of with AI tutors is that you can have a tutor teach you different things in general. So I'm not sure if that answers your question in detail.
No, I think it's great. I mean, as you noted, the fact that internet access is at a premium and difficult to get. It's not as easy to just say, hey, go download all this content, for example. But it's shipping someone something that's ready to go, that's focused, that has a curriculum around it. I could see the huge benefits to that for a student to have that, to have that personalized tutor one-on-one experience and have it be guided. It's kind of it just kind of makes me think about when we've got almost too many options, and a lot of latency, you could waste a lot of time. So here, having a curated curriculum and tools that are quite responsive to you would be huge. So I love it. I love what you're doing.
Thank you.
Yeah, all of these demos they're so unique in their own way, but what I think is cool to see is that each of you, is picking like, okay, let's look at like the 3 main things of Dagger, of what it solves in general, and what is a use case that specifically can be solved with Dagger, with Dagger's features. And so like, having the multi-language, the using it locally, the caching, like it's fun to see all of those different ones picked in each of these demos. And then, and then you just take it even further with all these awesome use cases. So thank you everyone for joining. I think we also have some announcements coming out today as well. So that's a good reminder for everyone to join our Discord, and also check out our blog, follow us on social. You'll see some stuff come out right after the community call, I think. So I haven't checked the Discords, but I think something's coming out today. So keep an eye on that. Thank you again for all of you tuning in to watch us today, and for all of our speakers here. Reminder that we will turn these into demo snippets. We'll throw it in our Discord in the demo forum, and you'll also find it on YouTube. So make sure to subscribe so you get those alerts. And then that way you can ask any follow-up questions to our speakers too. So thank you, everyone. Have a wonderful day.
Yeah, thanks, everybody. Awesome.
Thank you, everyone.